Hello and welcome back. So far we understood how logistic regression works and how it takes 0.5 as the threshold to distinguish between two classes. So the linear decision boundary, right, the line which actually distinguishes two classes is called as linear decision boundary. In classification, the linear equation tries to distinguish two classes, whereas in regression, the linear equation is trying to fit through the data. So here in logistic regression or classification setup, this line is distinguishing the records, the 1 records and 0 records. So on this line, it is equal to 0, the equation equal to 0. Below it, it is less than 0. Above it, it is greater than 0. When you put the same equation into logistic regression function, it becomes like greater than or equal to 0.5 and less than 0.5. So this is, for this particular example, the x-axis and y-axis are getting, touched at 3. So the equation is going to be minus 3 plus x1 plus x2 is a linear decision boundary which is distinguishing these two classes. So the logistic regression algorithm, when you pass your train data and train the model, it is going to find out the minus 3, the coefficient for x1 and coefficient for x2. 1, 1 and minus 3 it's going to find out. That is how it's going to look like here. So this is the linear decision boundary at a 0.5 threshold. Let us take one example and try to understand how exactly the prediction is happening. I said that the logistic regression's hypothesis function is going to generate probability, a number between 0 and 1. And I said that it is going to make predictions using these numbers by taking a threshold 0.5. Let us take a small data set where there are two classes, triangle and circle are the target variables and x1, x2 are the inputs. We don't care about x1, x2 right now because we need to make predictions or we need to understand the logistic regression setup. So the y value I can actually transform triangle as 1 and circle as 0 and make it as a binary class classification problem. When I pass this data x1, x2 and y to logistic regression, the logistic regression algorithm will generate the probabilities like this. For the first record it generated 0.6, second record it generated 0.3, third record 0.2, like that. The scikit-learn's logistic regression algorithm will actually take a threshold 0.5 and try to make it as a true or false. The 0.6, it converted it into a true by taking the threshold. If you take this series object or a numpy array and do greater than or equal to 0.5, all these numbers will get converted to true and false. I think you know that and you remember it. So if you say h of x greater than or equal to 0.5, 0.6 greater than or equal to 0.5, that is true, we can consider it as 1. So the actual y value is 1, the predicted value is 1. 0.3 greater than or equal to 0.5, it is false, it is not, right? So it is going to be 0. So predicted value, actual value is 0 and predicted value is 0. Like that it will make predictions. But if you look at the fourth record, the model, the logistic regression algorithm found out the probability as 0.4. When I try to apply this threshold 0.5, it actually said that it is false. 0.4 greater than or equal to 0.5 is false. So it is 0. So the prediction is not equal to the actual value. Similarly, at the sixth record also, the algorithm failed to predict correctly or classify correctly. Because of the threshold, it was unable to predict these two records correctly. So out of the 10 records, we were able to predict 8 correctly and 2 wrongly. We have got 80% accuracy. We know that the threshold is the one which is making the predictions, right? So if you change the threshold to 0.4, see that this record and this record, fourth record and sixth record also got predicted correctly. We have got 100% accuracy. So by changing the threshold, you can make the model work the best. Because of knowing the internal details, right, logistic regression, how it works, we were able to play with the threshold and made the model give you 100% accuracy. So this clue will give you more control over the model. Let us try to see the next slide and try to understand more about decision score. So far we have seen the probability, right? The logistic regression algorithm trying to emit a number between 0 and 1. So if you have two classes, the algorithm will generate two probabilities. The main probability it generates for the class 1, and for the class 0 it is going to be 1 minus probability of class 1. P and Q. Q is equal to 1 minus P is the probability. So it's going to generate two probabilities. For every record, it is going to generate two probabilities. A probability for 0, a probability for 1. Whichever is high, the record belongs to that particular class. But we have seen here the probability for 1, and we played with the threshold and we made the model the best. Okay? But if you look at the decision score, it is the distance between the decision boundary and the data point. The signed distance of the sample to the hyperplane. We said hyperplane because on a two-dimensional setup it's going to be a lane. In three-dimensional setup and beyond that it's going to be a hyperplane. So if your record is positive, the decision score is going to be positive. If your record is negative, the decision score is going to be negative. So 0 is the threshold for the decision score. We will use decision score to play with threshold and make the model the best. As we have done it here with the probability, in real time, we will play with decision score because it's going to give one set of values rather than two sets of values. Probability for 0 and probability for 1. Decision score is going to be one number which actually tells you whether the record belongs to the negative class or positive class by looking at the sign of the decision score. So 0 is the threshold for the decision score. Default threshold for logistic regression on decision score is 0. There are two ways you can actually understand or find out the predictions. One is probability or the logistic regression's the sigmoid function's outcome, or decision score. Decision score is the distance between each data point and the decision boundary. So we will see how to find best threshold to improve the model's performance. In one of the sessions, I actually explained that some problems need high precision and some problems need high recall. When you try to achieve high precision and high recall, what happens to the other one? When you try to achieve high precision, what happens to recall? When you try to achieve high recall, what happens to precision? We will understand all these things in coming session. Thank you.